All right, so now we're supposed to use the rational zeros theorem to make a list of all possible rational zeros. So we have 20 as our a0, and our an is equal to a -2. Okay, so we need all the factors of 20 and all the factors of 2. So here we'll have, 20 and then 10. And then if we go down, then we'll have 5. And then we go down, we'll have 4. And then we'll have 2. And we'll have 1. And again, all I did was I kind of thought about this. We had, 2 and 10, 1 and 20, 4 and 5. And now I have 1, 2, 4, 5, 10, 20. 1, 2, 4, 5, 10, 20. Okay. Now this one is going to be basically factors are going to be 1 and 2. Now remember, it's plus minus p over q. So if one of these is a negative, such as this one here, what happens is we have, a -2, and it's going to be, let's just use the 1 for instance, and it's plus or minus that. Well, that becomes, plus 1 over -2, so it becomes a -1/2. And now if we have a -1 over -2, that becomes 1/2. And so we have plus or minus still. And so we're going to ignore those kind of plus or minuses here. It's only going to look at the plus values, okay? Because it'll just change it to a negative over positive instead of positive over negative. And those are the same things. So let's look at our positive and negative p's over q's. So we can have 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1, 20 over 1. And then we could have 1 over 2, 2 over 2, 4 over 2, 5 over 2, 10 over 2, and 20 over 2. And those are all plus or minus. Now let's simplify. That's just 1 plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. And then we have plus or minus 1/2. Well, 2 divided by 2 is 1. We've already got it, so we're good there. 4 divided by 2 is 2. Well, we've got it, so we're good there. And then plus or minus 5 over 2. Well, 10 over 2 is 5. We've got 5 already, so we're good there. And 20 over 2 is 10. Well, we've got 10 already, so we're good there. Okay, so that is then our list. And again, it just says make a list of all the possible rational zeros. So that would be our full list of rational zeros. Okay. And again, we had to factor all our 20 here, and we had to factor our 2. And so again, we're just using the positive values there. So we don't have to worry about the negatives, because when you divide positive by a negative, it's negative, and you divide a negative by a negative, it's positive. And so you still end up with the plus or minuses. All right, so now we're supposed to use the rational zero theorem to find all possible zeros and then find all actual zeros. So that means synthetic division. Okay, so we're going to do the same thing here. So we have 3, 2, 1, 0. So our P is 6. So that's going to be basically a 1, a 2, a 3, and a 6. And our Q is going to be 3. So it's going to be 1 or 3. So our plus or minus P over Q is going to be plus or minus, and then we have 1, 2, 3, 6 all over 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, because they're all over 1. So we're saving that step of switching them. And then we have all of these over 3 as well. So plus or minus 1/3, plus or minus 2/3, plus or minus 3/3. Well, 3/3 is 1, so we won't do that one again. And 6 divided by 3 is 2, so we won't do that one again. So those then are basically our whole list of possible zeros. Now we better figure out how many positives and negatives we're going to see. This is our original 3, 2, 1. So we have one change. So it's going to be one positive real. Now if we put f of negative x, that becomes negative 3x cubed minus x squared plus 11x minus 6. We have, let's see, no, we have 1, 2, so 2 or 0, negative zeros. Okay, so now we have to start looking for them. So, I guess basically we're just going to have to start going through there and finding our zeros. What is the best way to do it? I don't know. It looks like there's more negatives than positives, so maybe that would be a way to start. Um, Another thing I've noticed in a lot of these, if we start with fractions first and then move our way to the whole numbers when we have fractions involved, those sometimes are going to be a possible way to do it. So I would say the one with the most possibles I would start with, which is negatives, and then I would start with fractions and work my way down to the whole numbers there. So what would I start with first? Well, let's start with, let's go from left to right and we'll go with negatives. So negative 2/3. And so what do we have here? We have a 3, and then we have a -1, -11, -6. Okay. So what do we have here? That's 3. Multiply that. The 3's cancel, and we get a -2. That becomes -3. Now the 3's cancel, negative, negative, so it's going to be a +2. Subtract that, that's going to be a -11. Now 3 goes into 9 3 times, so 3 times 2 is 6, and it's negative times not negative is positive. 6 minus 6 is 0, so hey, we found our first one. And again, I've noticed, and doesn't always work, but I've noticed again as we go across, I would always start with our fractions first, and then do our whole numbers. And since I have negatives I'm doing first, I'm going to start with the negatives. Just go that way. I would have done negative 2/3, -1/3, -6, -3, -2, -1, and figured out what I've got from there. All right, so that's an x squared. That's an x, and that's my number. So we have 3x squared minus 3x minus 9. All right. Well, what does that give me? Well, that gives me equals 0. That gives me something I can say, well, hey, I see a common factor of 1/3 in there. So let's multiply everything by 1/3. That gives me x squared minus x minus 3 equals 0. Now, can I factor that? I don't know any two factors of 3 that give me a -1. So guess what? We gotta go back to the theorem here. So minus a -1 plus or minus square root. A -1 squared is 1, minus 4 times a, which is 1, times c, which is -3, parenthesis, all over 2 times a, which is 1. So that gives me x is 1 plus or minus square root of, here we have 3 times 4 is 12. It's a positive. Plus 1 is 13 all over 2. And so that gives me two more roots. We get x equals 1 plus the square root of 13 over 2, and then we get 1 minus the square root of 13 over 2. And so my factors are going to be x equals -2/3. That's one negative. And then we get x equals 1 plus the square root of 13 over 2. That's one positive. And guess what? We said we have one positive. And then we get x equals 1 minus the square root of 13 over 2. And now the square root of 13 is going to be greater than 1, so that's going to be also a negative. So that gives me two negatives, which would be this, and one positive, which is this. And so that makes sense. I have three factors. That's how many I should have had. And so I would say that would probably be the correct value. Again, I started with the most possible, which is the negatives, because that's more of them, so I have a better chance of hitting the luck on one of them. And then I did fractions first. And because, I wrote this out with the fractions at the end, really usually fractions would be, you do the fractions and then you do whole numbers. And so I would do it that order. But again, I always would try the fractions first because for some reason, those seem to be usually the case what happens to work. All right, so let's pause there and we'll come back for some more.